Welcome back, fabulous fifth graders, to another super fantastic math lesson. We are going to continue on talking about multiplying with fractions. Last week we talked about multiplying fractions by fractions. The week before we had talked about fractions by whole numbers. And this week we're going to dive into multiplying with our good old friend mixed numbers. So you remember that hopefully that a mixed number is just a whole number and a fraction combined together. So as you can probably predict, we are going to be taking our knowledge of multiplying fractions and our knowledge of multiplying whole numbers, and we're going to mix them together using the algorithm that we had talked about last week to help us have a deeper understanding of how we're multiplying with mixed numbers and how we get to the correct answer. So before we start, I figured we could just go back to some basic multiplication just to kind of get a feel for where these answers are coming from, how are they logical, because you're going to notice that your answers are not as big as you would think. So why is that? What's the logistics behind that? So let's just kind of talk about what multiplication is. So it is a repeated amount for a certain number of groups. So if we're thinking about 3 times 5, go back to maybe 3rd grade, and you should be thinking about it being 3 groups of 5. And this is what we did in 3rd grade, right? You drew the visual. You have 3 groups. They're my 3 circles. And I put 5 in each one. How many do I have altogether, right? And it's repeated addition, as we've talked about already. And you can apply that same thought to fractions. So we took this idea of whole numbers, and we broke it up and we worked with fractions a couple weeks ago. And we said, hey, how does this work with fractions? Well, 3 times 1/5, that's really just saying, what's 3 groups of 1/5? So what would that look like? Well, I start off with my 3 groups, just like I did in the last problem, except this time, instead of putting 5 holes in each group, I'm going to break my group up into 5 pieces. And I have 1/5 of them. So you would see something like this, where you have 3 groups. They're each broken up into fifths, and I have 1/5 shaded in purple there. So how many do I have all together? Well, I have 1, 2, 3 fifths all together. So it's an answer smaller than what I started with, but I have 3 groups of 1/5. How many fifths do I have? I have 3 fifths. 3 pieces are shaded purple out of my whole, which was fifths, because that's what I broke each group into. So that was something we had talked about a couple of weeks ago. If that's still confusing and a struggle for you, please reach out, because everything we're going to do moving forward is going to keep going back to this same idea. So it's really important that you're understanding this concept. I know we also talked about shading it all in one group as well, and so perhaps you're thinking of maybe one box with 3 different colors on it, and that would be fine too. You'd still get 3 fifths as your answer. So just make sure you're feeling okay with that, and if not, please reach out. So now we're going to take this same idea, the one of 3 times 5, what that looks like, and 3 times 1/5 and what that looks like, and we're going to combine them together to look and think about what a mixed number would look like. So here we have 3 times 1.5. So what would that look like? So hopefully you're thinking about 3 groups of 1.5. And I'm going to use an example of apples, because that's something that you could have 1.5 of, right? Make sure it's kind of logical. So let's think about something like this. So I had 3 groups of 1.5 apples. So you will notice I have 3 bowls, and each bowl has 1 whole apple and a half of another one. So now if I have 3 bowls of apples, and they each have 1.5 in them, how many apples do I have all together? Well, I can clearly see I have 3 full apples, and then I can kind of piece the halves together. So I'm going to end up with 4.5 apples. And the number line is a great resource for this as well, because I'm going to add 1.5 every time. We know multiplication is just repeated addition, so feel free to do that as well. We also know how to add fractions, especially if they have the same denominators. So you can go back to any of those other resources that you have in your toolbox as well to kind of help you get to this answer. But I like the visual of thinking about 3 groups, 1.5 in each group. How would I add that up? So how would that look? And here's your answer, 4.5, as we had talked about. And maybe your answer is a little bit smaller than what you might think of, or larger. I'm not sure how you're thinking yet. Sometimes I feel the answers are a little tricky to these, but we'll get there. So what if we didn't draw the visual? What if we weren't drawing apples? What if we weren't drawing circles with 1.5 in each group? What if we weren't doing the number line? How could we take what we learned last week and apply it to mixed numbers? So we know a mixed number is really just a fraction, right? So we know that we can take our algorithm and use it as long as we have 2 fractions. So we can change our 2 fractions, our 2 numbers, I should say, into improper fractions. And we talked about whole numbers last week, how whole numbers can all be improper fractions by placing a 1 as the denominator, because a 3 is really 3 wholes, 3 out of 1, 3 full groups. And then 1.5, hopefully you remember from before, we can change that to an improper fraction by multiplying our denominator of 2 times 1, our whole number, and then add our extra numerator piece of the additional 1. So 2 times 1 is 2, plus 1 more gives us 3. And you can always double check that 3 halves, is that the same thing as saying 1 full group and a half of another group? And you got it. Once you have those 2 fractions, so I've changed 3 to 3 out of 1, and then 1.5 to 3 halves, now I can just use my algorithm, which we talked about is one of the easiest math concepts to complete for fractions because you don't need any common denominators. So you're just going to, once you have the fractions, multiply straight across. 3 times 3, 9. 1 times 2, 2. And then simplify it. So 9 halves. How many groups of 2 can we take out of 9? Kind of thinking about division, right? 9 divided by 2. That's 4 full groups. And I have 1 left over. My denominator stays the same, so I have 4.5. And I believe, if we go back to our last slide, we had 4.5 apples. So you get the same answer. Okay, so let's kind of sum up how we multiply with mixed numbers. We're going to first change our whole numbers and our mixed numbers to improper fractions, keeping in mind that all whole numbers can be fractions with a 1 as the denominator because it's wholes. Once you have the 2 fractions, you're ready to go with the algorithm. Multiply the numerators, multiply the denominators, and then simplify them down to mixed numbers as you see fit. I know some people are stretching and simplifying even more, which is great. So that's about it. It's as simple as that. As long as you're remembering the precursory steps, which is, do you remember how to change an improper mixed number to an improper fraction? And your math facts. Once you know those things, you're pretty much in good shape, and then how to change that improper fraction back. If you need help with any of those items, we are here for you. So please reach out, and we will support you the best way that we can to make sure that you are successful. Thank you for joining us for another fabulous math lesson here in 5th grade, and we look forward to seeing you again soon.